They stand like frozen waves of stone, rising above the clouds, their peaks cutting into the sky. To anyone who looks at them, mountains appear eternal, unchanging, unmovable, timeless. But what if I told you that these mighty giants are alive in their own slow, silent way? That every single year they move. Not in a way we can see with our eyes, but in a way that shapes the earth beneath our feet. It sounds impossible, doesn't it? Mountains, moving? But this is one of nature's quietest miracles. The solid rock you see when you look at a mountain range isn't as still as it seems. Beneath that calm, majestic face lies a restless heart, constantly shifting, bending, and even growing. Imagine standing on the top of Mount Everest, the highest point on Earth. The wind screams past you, the cold bites your skin, and everything feels eternal. Yet, while you're standing there, the mountain itself is rising. Slowly, almost invisibly, but rising nonetheless. Scientists estimate that the Himalayas grow about 5 millimeters every year, about as fast as your fingernails grow. It's a tiny change, but over millions of years, it's enough to create the world's tallest peaks. But how is this possible? How can solid rock move? The secret lies deep beneath our feet, in the Earth's crust. Our planet isn't one single solid shell. It's broken into giant pieces called tectonic plates, and these plates are always drifting. They move only a few centimeters each year, but that slow movement carries unimaginable power. When two plates collide, one pushes against the other and the crust buckles upward, forming mountains. That's exactly how the Himalayas were born, when the massive Indian plate began crashing into the Eurasian plate around 50 million years ago. That collision hasn't stopped. The plates are still pressing against each other today, like two unstoppable forces locked in a slow-motion struggle. Each year, that pressure makes the Himalayas a little taller, and also causes deadly earthquakes as the land releases its tension. Now here's something fascinating. Mountains don't just rise, they also fall. Over time, wind, rain, and glaciers wear them down. The same forces that create mountains also destroy them. It's a never-ending battle between the upward push of Earth's crust and the downward pull of erosion. In a strange way, mountains are like breathing giants, growing, shrinking, growing again, each breath taking millions of years. If you could watch a time-lapse of Earth over the last 100 million years, you'd see the continents drift like rafts, mountains erupt out of flat plains, and entire ranges crumble into dust. To us, a mountain might look eternal. To the Earth, it's just a moment. And here's a fun fact. Even the tiny movements of mountains can be measured today. Scientists use GPS technology so precise it can detect shifts smaller than a millimeter. That's how we know Mount Everest isn't standing still. It's slowly moving northeast every single year. When you think about it, that means the world map you learned in school is always changing. Every mountain range, every continent, every coastline is on the move. We just live too slowly to see it happen. Far beneath our feet, beneath the soil, the rocks, and the deepest caverns, there's a world we never see, a world that never stops moving. It's the secret engine of our planet, and it's the reason mountains move, rise, and crumble. Imagine Earth as a giant, breathing machine. The surface, what we live on, is like a cracked eggshell split into enormous slabs called tectonic plates. These plates fit together like puzzle pieces, but they're not fixed. They float, ever so slowly, on a sea of molten rock called the mantle. The mantle isn't completely liquid. It's a thick, almost syrupy layer of hot rock that moves in slow, swirling currents. This motion, called mantle convection, is driven by the intense heat from the Earth's core, the same core that's as hot as the surface of the sun. As this heat rises, it pushes the plates above, causing them to drift. Now here's the amazing part, the plates move only a few centimeters a year. That's about as fast as your fingernails grow. Yet this tiny movement has created the world as we know it. Continents, oceans, islands, volcanoes, and of course mountains. Wherever two plates meet, something extraordinary happens. Sometimes they pull apart, creating new crust, like at the mid-Atlantic ridge where Iceland is slowly being split in two. Sometimes one plate slides beneath another, plunging deep into the mantle, a process called subduction. And sometimes two plates simply crash head-on, crushing everything in between. That's what creates the tallest, most awe-inspiring mountain ranges on Earth. Take the Andes in South America. Stretching across 7 countries, they were born from a collision between the Nazca Plate and the South American Plate. The Nazca Plate slides under the continent, forcing the crust upward, and every year the Andes rise just a little more. But the pressure doesn't build evenly. Sometimes, it locks in place for centuries, and then suddenly releases in a violent earthquake that reshapes entire valleys in seconds. Now think about the Alps in Europe. Millions of years ago, Africa began drifting northward and slammed into Europe. The collision squeezed layers of rock together like dough, folding them over themselves until they rose into the snow-covered peaks we see today. Even now, the Alps are still growing, just a few millimeters a year, while erosion slowly wears them down from above. It's a race between creation and destruction, and the finish line is never reached. And here's a mind-bending thought. Mountains aren't fixed to one place forever. Because tectonic plates drift, entire ranges move across the planet over time. Scientists believe that millions of years from now, new supercontinents will form, and the mountain ranges we know today will be in completely different places. There's a place in California that shows us what happens when plates slide past each other instead of colliding. It's called the San Andreas Fault. On one side lies the Pacific Plate, on the other the North American Plate. Every year they slide past each other by a few centimeters. It's so slow that we don't feel it, until the plates suddenly slip, causing a massive earthquake. The same forces that move continents are the ones that shake cities. What's truly astonishing is that all this movement, all this power, is happening under our feet right now. While you sit, stand, or walk, the ground beneath you is moving. You don't feel it, you don't see it, but the earth never stops shifting. And the story doesn't end there. Because as mountains move, they change the climate, the rivers, even life itself. The rise of a mountain range can alter wind patterns, block rainfall, and give birth to deserts and forests alike. The movement of mountains isn't just a geological process, it's the heartbeat of the planet. Every mountain tells a story. Not just of rock and time, but of life itself. Because when mountains move, even by a few millimeters each year, they reshape everything around them. The air we breathe, the water we drink, and even the way civilizations rise and fall. Let's begin with something as simple as the wind. When a mountain range grows taller, it becomes a wall against the sky. Winds that once flowed freely are forced upward, cooling as they rise. This causes clouds to form and rain to fall, but only on one side. On the other side, the air descends dry and warm, creating vast deserts. That's how the Himalayas and the Tibetan Plateau shaped the Asian continent. When these mountains rose, they blocked moist air from the Indian Ocean, creating the Gobi Desert in the north and the dry plains of western China. Without those moving mountains, the map of Asia's climate would look entirely different. Now think about rivers. Every drop of rain that falls on a mountain begins a journey, carving valleys, feeding forests, and giving life to millions. But as mountains move and rise, they change the paths of these rivers. Entire ecosystems must adapt or perish. The mighty Amazon River, for instance, once flowed in the opposite direction, toward the Pacific Ocean. But when the Andes rose, they blocked its path, forcing the river to turn east and flow toward the Atlantic instead. That one geological shift reshaped the entire South American continent and gave birth to the world's largest rainforest. Mountains also shape the sky itself. The towering Himalayas push air so high that they influence the monsoon winds, the seasonal rains that billions of people depend on in India, Nepal, and Bangladesh. If the Himalayas stopped rising, those winds could weaken, and the world's most important agricultural systems could collapse. The slow movement of stone determines whether millions eat or starve. But the story doesn't stop with nature. It reaches into human history. The movement of mountains has guided migrations, built civilizations, and inspired myths. Ancient people saw mountains as sacred, the home of gods and spirits, because they sensed their power, even if they didn't know the science behind it. In ancient Greece, Mount Olympus was believed to be the home of the gods. In Japan, Mount Fuji became a symbol of purity and strength. In the Himalayas, the peaks were seen as stairways to heaven. Across cultures, mountains became symbols of permanence, the one thing that never changes. Yet, ironically, mountains are always changing. They are the Earth's slowest rivers, flowing not with water but with time. Here's an incredible fact. The rise of the Andes Mountains actually changed the chemistry of the ocean. As they grew taller, rain eroded the rock, carrying minerals into the sea. Those minerals fed microscopic life, plankton, which pulled carbon dioxide from the air. Over millions of years, this process cooled the planet and helped trigger an ice age. In other words, mountains don't just shape landscapes. They shape the climate of the entire Earth. It's humbling to realize that the solid ground we trust, the mountains we think of as symbols of strength, are in constant motion, subtly rewriting the story of our world. Every tree, every river, every living thing carries the signature of these slow-moving giants. And just like the Earth, life itself adapts to their rhythm. As mountains rise, species evolve, birds grow stronger wings, plants cling tighter to cliffs, animals find new ways to survive in thinner air. Even humans have changed because of mountains. People living in the Himalayas and Andes have developed lungs that can absorb more oxygen. a direct result of the mountain's movement over millions of years. So, when we say mountains move slowly, what we really mean is that they move powerfully. They are the sculptors of nature, the authors of climate, and the silent partners of evolution. For thousands of years, humans believed mountains were eternal. They marked borders, defined nations, and stood as symbols of permanence. But today we know something astonishing: mountains move. And the proof doesn't come from myth or legend, it comes from science. High above the Earth, satellites orbit silently, their sensors aimed at the surface. Every second they record the tiniest shifts, movements smaller than the width of a human hair. Using these satellites, scientists can see what no human eye ever could: entire mountain ranges drifting, rising, and tilting in real time. Let's take the Himalayas again. Using GPS monitoring stations scattered across the range, scientists discovered that the mountains move northeast by about 5 centimeters every year. It may sound like nothing, but over a human lifetime, that's several meters. Over millions of years, it's an entirely new world. These precise measurements have revealed something incredible. Mountains don't move smoothly. They move in bursts. Pressure builds up underground for centuries as tectonic plates push against each other, locked in a silent struggle. Then, suddenly, that tension snaps. In seconds, an earthquake sends shockwaves through rock that's been still for ages. This is how earthquakes are born. They're the sudden release of movement that's been happening in slow motion for millions of years. The 2015 Nepal earthquake, for example, was caused by the same collision that built the Himalayas. In that moment, a piece of Earth's crust slipped, and parts of the mountains jumped forward by several meters. What feels like disaster to us is just another breath for the planet. But how do scientists study such ancient and enormous movements? They look into the rocks themselves. Inside every layer of stone lies a memory, a record of pressure, temperature, and movement frozen in time. By studying the minerals in mountain rocks, geologists can read the story of how deep they once were buried, how fast they rose, and when they began to erode. It's like opening the diary of the Earth. Some scientists even travel to the bottom of the ocean to find clues. When two plates collide, one often gets pushed downward into the depths of the sea, carrying rock from the surface along with it. Millions of years later, that rock can be thrust back up to form new mountains. Finding seashell fossils on mountaintops isn't a miracle, it's a sign of the Earth's restless motion. One of the most astonishing examples is Mount Everest itself. Near its summit, scientists have found fossils of ancient marine life, proof that the world's highest peak was once at the bottom of an ocean. The Himalayas are literally made of seabed stone, pushed skyward by unstoppable tectonic force. Now, with technology more advanced than ever, scientists are combining GPS data, radar imaging, and computer simulations to predict how mountains will change in the future. Some models show that the Himalayas could rise another 1,500 meters in the next 10 million years, while others might erode away faster than they grow. The Andes, meanwhile, could shift eastward, changing the course of rivers and even the Amazon basin itself. The continents continue their ancient dance, drifting, colliding, reshaping the Earth inch by inch. What takes place over millions of years is, in a way, the slow-motion heartbeat of our planet. And as scientists uncover more, one truth becomes clear. We live on a living planet, one that moves, breathes, and grows. The movement of mountains isn't just geology, it's the rhythm of the Earth itself. From the outside, mountains seem unshakable, the eternal guardians of the Earth. But now we know their secret: they are not still. They move, they breathe, they rise, and they fall. Slowly, silently, but always. If you stand at the base of a mountain and look up, you're seeing something that's both ancient and alive. Every ridge, every cliff, every line of snow tells a story millions of years in the making. A story still being written right now, as the Earth continues its endless dance beneath your feet. Think about it. Every single step you take on solid ground is actually on something that's in motion. The mountain you climb today might be a few millimeters taller tomorrow. The valley you walk through might sink ever so slightly next year. The planet itself is never resting. It's always reshaping, reinventing, renewing. To us, it happens too slowly to notice. But to the Earth, it's the blink of an eye. If we could watch time sped up, days flashing by like seconds, we'd see continents drift across the oceans like ghostly ships. We'd see mountains grow and crumble, seas vanish, and deserts bloom where rainforests once stood. The entire face of the Earth would move like breathing, slow, steady, unstoppable. Mountains, in their movement, teach us something profound. Change doesn't have to be fast to be powerful. The slowest forces are often the ones that shape the world most completely. Take the Appalachian Mountains in North America. Today they are gentle, forested hills. But once, hundreds of millions of years ago, they were as tall as the Himalayas. Over time, wind, water, and ice wore them down, grain by grain, until only their quiet bones remain. Yet even in their worn beauty they continue to move, ever so slightly, a reminder that nothing on earth is truly finished. And someday the same will happen to the mighty Himalayas. The same mountains that now pierce the clouds will one day erode into valleys and plains. The earth will recycle their rocks into new crust, and perhaps in another corner of the world, a new range will rise, younger, taller, ready to begin the cycle again. It's a cycle that never ends: creation, destruction, rebirth. Mountains are not monuments of stillness, they are expressions of time itself. Even humanity's greatest achievements, our cities, our monuments, our civilizations, are built upon this ever-moving foundation. We live our entire lives believing the ground beneath us is solid. But in reality it's drifting, folding, and reshaping beneath our feet. The earth is alive and we are passengers on its back. Here's something to think about. In 250 million years, scientists predict that all the continents will merge once again into a new supercontinent, a single vast landmass surrounded by ocean. New mountains will rise, new seas will form, and everything familiar to us will be gone. The earth will look completely different, yet the same forces that shape it today will still be at work. Slow, patient, eternal. When we look at a mountain, we're really looking at time made visible. Each layer of rock is a page in Earth's diary. Each peak is a reminder that even the most powerful things in nature are never still. And maybe, just maybe, there's a lesson for us in that. That movement, no matter how slow, is what keeps the world alive. That patience and persistence can create miracles, even out of stone. So, the next time you see a mountain, don't think of it as something ancient and unmoving. Think of it as a traveler. A slow wanderer in the great story of Earth, inching forward year after year, reshaping the planet, and silently whispering the truth of our world. Nothing is permanent. Not even the mountains.